All right, there we go, YouTube time. So I'm back to uploading locally recorded versions since I'm back home. Okay, so like I said, today we are talking about double linked list, but first I do want to bring up what a circular linked list is, because that might be a term you might run into at some point in time. In fact, when we do queues, a circular linked list kind of works out. So, well, you can use it, but you don't really use it, but it is there. So let's talk about what a circular linked list is, just really fast. So far, we have been talking about singly linked list, and a circular linked list can also be a singly linked list. It can be double linked list as well, but we haven't talked about those yet. We will talk about them today. So let's just talk about what a circular linked list is overall. So suppose that we have the following linked list. We have our head pointer. We haven't really talked about it, but it is possible to have a tail pointer. Sometimes useful, not necessary. That's why we haven't really mentioned it, but it does exist there. But yeah, that's pretty much all we got. So now my thing is, if I want to make this into a circular linked list, all I got to do is, instead of making the last pointer at the end null, all you do is you make that point to the head of the linked list. So right there. And voila, you have achieved a circular linked list. An anonymous cheer. Is that actually the nickname of the person, or is it really anonymous? Interesting. So really, I try to make it a circle, but it would take a while. But that's where the name circular linked list comes from, is that you're kind of basically making a circle. There we go. Kind of looks like the interstellar ship. But yeah, that's the circular linked list. That's all there's to it. Okay? So not something we're really going to mess around with this class a lot, but just be aware if you hear the term, that's what it is. The problem with doing this is that now there is no concept that's inserting at the end of the list, because there's no end. It's just a circle. It goes on. You have some sort of entry into this, which is like a random node has a pointer that we call head, but like there's no really beginning or end because it's a circle, right? You can still insert into like a sort of sorted version to this by making sure that if you see the number next to you being smaller, that's technically the end of it. And you can still say insert 5 spots after the head. You can still command where to insert, but it doesn't have many usages that I can think of just off the bat. Okay? But just wanted to bring it up in case you ever hear that term, you don't freak out and you're like, whoa, what is this circular linked list thing? Okay? But now for the main course of the day, which is a double linked list. So I don't know if you'll know Star Wars. That's where the quote came from, twice the pride, double the fall by Count Dooku. In this case, with double linked list, it's twice the links, double the sec fault. Because yes, the only fun part of a double linked list is trying to debug a double linked list, which is, well, not really fun, but there's more pointers involved, and more pointers is usually more chances of things going wrong, right? So let's start by just giving you, fun, like F is for friends, and what is the SpongeBob thing? And then what the plankton says of fun, that's the one. So yeah, all right. So with a singly linked list, we have two main components to a node, right? Yes, that's another Count Dooku quote. Look forward to this, yeah. All right, we could do this all day, but yeah. So we have the two major components that we have is the data component, which usually contains, well, you can make a template, contain whatever data you want, etc., etc., etc. And then you have your, usually we call it like the next pointer. Oh, things really get trippy when I flip it sideways, so I can write sideways. There we go. So we usually call this the next pointer, lowercase n, I guess, but still. And that's your pointer to your next node, right? And that's really your two components of your linked list node. And of course, you make a linked list by putting a bunch of these together. I use this little circle to represent like a null PTR, okay? So, then, a double linked list all it's going to do is going to add one extra component, and it's going to be one extra pointer per node. And from a drawing perspective, we tend to put that here, and we're going to call that, well, again, you can call whatever you want, but what I like to call it and what I've seen people call it is the previous pointer, prev. Okay? Like that. And now you have achieved a doubly linked list. The word doubly because it has double the links. So double, two. Okay? From a single to a double. It's like, how would you like your burger? Single or double? All right? So that's it. That's all there's to it. Literally, this is a double linked list. The end of the story. Now, why are we spending a full day on this then? Well, because when you're implementing this and you're trying to Lego together a bunch of these, you don't have to now just worry about one pointer. You have to worry about 2 pointers, right? And that's why we're spending a day on it, because we have to update our code basically to think about all the different scenarios of inserting things and removing things and all that stuff. So here I got a little example of a double linked list. Now it's kind of long, so I put it in 2 sides, and this time I draw it ahead of time because when you try and draw it live, it's not that nice. And so as you can see, every single node is connected to another node. In the past, each node was connected by one link, right? One ahead, and that's it. Now we got one ahead and one back. And what that means is the biggest power of why this is useful, like, okay, why are we doing this? Like, why can't we just stick to a single link list? You can do the same things that you can do with a double. You can, but there's one thing you can't do with a single that you can do with a double, at least easily, and that is go in the other direction. So if your single goes like this way, if you want to go backwards, like if you want to print the linked list backwards, I showed you that last week. What I did is I used recursion for that. And that's a little trick you can do to print the list backward. But outside of that trick, there isn't really a way to run backwards with a singly linked list. With a double linked list, you can go in both directions. You can go forward and backwards. What that means is that you're able to traverse any way you want. Go back, go forward, move one up, move one down. Now, if you remember back to the code that we had last week, we had to keep track of the previous node because when we got to the end of the linked list, we had to remember the node before. That was a little bit of a hassle when you're coding it. You don't have to do that here because you got a pointer to go both directions. It's like you're no longer going a one-way road. You have a 2-way road, and you can change directions anytime you want. So it adds a lot of flexibility. And it only costs 1 extra pointer per node, which is a small amount of space when you think about it. Now, when you're inserting a node, such as here, let's say you want to insert a node right here, it's no longer just updating 2 pointers. And by 2, I'm saying, well, if we're going to insert right there, we want to update this pointer, and then probably we want to update the pointer of whatever we're inserting. So like if it was a single linked list, we would update that pointer and this pointer, right? But because it's a double linked list, now we're going to have to update also this rear pointer here. And by that scenario, we're also going to have to update this pointer here. So this one's going to have to be linked to that. And this one's going to have to link to that. Okay, so you're going to have to update more pointers, twice the amount of them, double linked list, to be able to insert things. But other than that, that's all there's to it. So there's no high science. It is definitely useful to have a tail pointer, so a T pointing to the last node on a double linked list, because that does allow you the flexibility to go backwards if you need to. So you do want to have that, and I am going to implement that in the code that I do today. You're also going to notice that because it's a double linked list, that the last node does have the null as the next pointer here. So that still exists. But now we also have a null in the first node because there's nothing before the first, okay? And you can also make a circular double linked list as well. You just have to link those 2 together that I'm having there to point to, like the first node points to the tail and the tail node points to the head, as there, and make a circle, but don't worry about that. Okay? So that's all I gotta show you. Now let's just code it up so you can see it, and then you can use that code in the future and whatnot. But we're gonna start from scratch. We're gonna do a clean version of the code, and this time I'm gonna make it templated, because I do think in your assignments you gotta make it templated, so might as well do templated. Okay, so we got a clean slate. All right, it's nice to be coding back in this. So I'm gonna call it node again. It's been a couple of weeks now since I coded templates, but I think I'll remember them, I hope. I'm gonna make my life easy. I'm gonna keep this shorthand, so I'm gonna call D and N instead of node, just to we can code faster that way. I would recommend you always call them data and node, but oh yeah, if I do node, then I'm gonna run into, well, yeah, I can do N and P. So data, next, and previous. Yeah, so I'll do that. It just makes my life easier for coding. But you know, Control F and like replace all instances in your version with the full word of the name. Okay, it's just, you know, I'm trying to get this coded in an hour, and not just coded, but working, which is the big catch. And template it. So yeah, we'll see if we can achieve that. All right, so that's your data, and then we have the pointer. So the pointer is of node type, but because it's a template, I'm gonna need to put that in there. Like that. I think that is all template. Save. And then the constructor. So for the constructor, I am going to go ahead and say that it takes one value, which is going to be your data component, and then it's going to initialize the next pointer to null and the previous pointer to null, and then the data pointer, the data value to data. Okay. Those, that's what I need. Okay, I think that's all good. Nope. Let's see what's wrong. Oh, semicolon. And comma. Actually, you don't need the semicolon. I don't think you need a semicolon. Yeah. There we go. Okay. Of course, I can make another thing that I initialize these to something, but that's okay. Yeah, I'm happy with this. I could make this dynamic, but then I gotta do rule of three, like overload the copy constructor, and that's more work. I don't have the time for that. But you could also make the dynamic, okay? So there we go. We have our node class, and now we are going to be making our double linked list class, okay? I'm just gonna call it DD or DLL. DLL, double linked list class. Okay, and it is going to have a head pointer, which is a node pointer. I'm just going to call it H again to save time. And then I am going to, Padme being toxic, sorry. I'm going to call my tail pointer T. Okay? And then head, tail, and that's it. I only need 2 pointers, so that's it. So yeah, there you go. I was like, might as well put the emoji of my dog. Padme. All right. So, okay. That's all there's to it in terms of objects. I do want to make this public all, because otherwise it's going to yell at me. And then I'm also going to make this public to make my life easy. And now we just need to make our inserts, our prints, and all that fun stuff again. So, how do we want to make the insertion. We just want to make one function. Let's do sorted again, so you can see the same code again. Because really, unsorted is much easier. So if we can do sorted, you can do unsorted at any time. In fact, we can update this to be a linked list or a stack next week when I go over those. So we'll let it be like this. We'll just make it a sorted double linked list. So for that, we're going to have an insert function that's going to take a value that we want to insert. So we'll call this value v. And then we are going to put it outside the class. And we're also going to have a delete so that we can delete some value if it exists. And then we want to have a print function. And we want to have probably a destructor to deallocate and a constructor as well. The constructor I'm going to put in, because all I'm going to do for that is I'm just going to initialize these to null. Like that. Okay? So, yeah. All right. We'll, obviously, we'll finish the destructor later. Yeah, we'll finish it later. Okay? So, let's go ahead and create these. We can actually just write them all 4 out so we don't forget to do the destructor. Now, what type of return type do we want for them? Well, they can all be void. So it's going to be void, class DLL. Oh, we got to write the word template here. Class T. Void DLLT ::. Yeah, I think that's the right syntax. Insert. And then that. Okay, so that is literally the same syntax we have to put for the delete, so I'm just going to copy paste it. Hopefully this is all template review. And for the print as well. For the destructor, though, we don't need to do the void. And why doesn't it like that one? Oh, well, we need those. Oh, don't call this delete, right? We'll call it del. Because delete is a reserved keyword. Why doesn't it like my template? My templated destructor? I don't know. Maybe that's just VS Code being weird. Or maybe it's because it needs these guys. Yeah, okay. Alright, so now we just got to actually write the code for the insert, the delete, the print, and the destructor. The destructor, no rush. Memory leaks, we can fix them at the end. Let's just go ahead and do the insert and the print. Actually, we could probably do the print right now. So for the print, all we gotta do is just print out the contents of our double linked list. So let's just go ahead and say cout DLL and then basically write a for loop. Or a while loop actually. While let's make a pointer. Let's call that pointer the temporary pointer. This is gonna be literally like copy paste of what we did before, which I don't have it next to me, but I remember it, so it'll look very similar. And if not, again, this will be even better because it's clean. It's always nice to write fresh code. So we'll call this cur, and we are going to say cur gets head. And oh, you know what we can do? We can do a reverse print, so you can see that how nice it is too. So I'll add that function later. Okay, back here so I don't forget it. Let me just write the prototype of it. So we'll call it rev print. And you'll see how easy it is to do. All right, so we can say while cur is not equal to null, go ahead and iterate by printing out the contents. So cout data, cout an arrow, because I like the arrow, and then maybe a space, like that. I like it. And then just do cur get cur next. Oh, just cur end. It's like that. Okay, and once it's finished, we want to add a line feed to that. So now, if I want to do the reverse, check out how easy that is. Oh, whoops, I put it on the reverse, my bad. Well, here, let me put it on this one. So for this, instead of assigning the head at the beginning, we assign the tail. And instead of doing cur next here, we do cur prev, because we use the previous pointer. And voila, we are done. Now we can print in reverse now. So that's how easy it is to use this double linked list stuff. Okay, but we won't get to see this working until we actually write the insert function. So let's go ahead and write the insert function. So again, we want to do a sorted linked list. And you know, we're hoping that because it's templated, that we only insert things that we have a greater than or less than operator that works with them. Otherwise, we have to overload that. That's a whole different story. Not going to do that right now unless we somehow finish this before the class ends. So let's just assume that it's numbers in our head to make our life easy. So we're going to do the same logic that we did before. And that logic is going to be that we want to insert at the start, at the middle, at the end. And within the start, we have two options, which is beginning of an existing list and then the other one being a empty list. Road to 10,000 points. I wonder if we can get them before the end of the semester. All right, so those are the four cases. We have 1, 2, 3, 4. Okay, so how we're going to do that is how we did before, which is the first thing we want to do in the function is we want to create a node with the data that we want to insert. So let's go ahead and make that TMP node. So TMP is going to get new node, and we're going to pass in v, which is the data that we want to insert. And this creates a new node and sets the previous pointer and the next pointer to null. So we're good to go. Next thing we need to do is we need to figure out where to insert it. So I'm going to go ahead and say, well, first of all, let's just do the case where the list is empty. So if head is equal to null ptr, then that means that the list is currently empty. And if that is the case, then I can just throw it in. So if that is the case, let's go ahead and say head gets TMP and tail gets TMP. So this is where things get changed, because now we need to make sure we also assign the tail pointer. Now this is also the same thing with the singular linked list, it's just we didn't do tail pointer there, because it's more useful in the doubly, but still useful in the singlet. So that's why I wanted to show you an example with the tail, but I didn't want to show it last time because that was another level of abstraction that you have to think about. So I wanted to make it the most bare bones simple linked list. Now we're trying to like accessorize our linked list basically. Okay? So yeah. All right, so we have head and tail. So that's all we gotta do. Now we're done. So else clause. Although to not make my code so horizontal, instead of doing an else clause here, I'm gonna go ahead and say return, and then I'm just gonna keep coding here, okay? But ideally you wanna do an else clause, just so I don't make the code so horizontal, so I have more space available, okay? So the next thing I wanna check is basically, well, the list is not empty, so I gotta insert it somewhere in the beginning, middle, or end, right? So let's go ahead and do that with a while loop. Again, we can make a temporary pointer, so we can say node star or node t star cur, which I'm going to use C to make it faster, less coding. And then I'm going to set that to be the head, which we know is not empty because otherwise we would have run this. So this is like, this is empty. So just insert. Okay, so I'm going to say, well, cur is not equal to null. Okay, so basically, whoa, I'm trying to get rid of that parentheses. There we go. Okay, what this is saying is, while we don't hit the end of the list. Okay, so that is going to basically take us either to the end of the list or it's going to take us to wherever we gotta insert. So if what we're looking at, so if cur data, if that is greater than what we're trying to insert, so temp data, so if the next node is greater than what we have, insert before. Okay? So that means that we gotta insert before this. But the list already exists, so we gotta be careful. If we want to insert before it, we need to know if there's stuff before us, right? And if there's stuff before us, we need to link it back together. We need to update the head pointer. We need to figure out if we're in the beginning or if we're in the end, right? So there's two scenarios right now. It could be at the beginning of an existing list, or we could be somewhere in the middle. So let's check to see which of those two scenarios we're at. If C is equal to H, then it means that we're at the beginning of the list. So we're going to insert at the beginning of an existing list. Existing list. I know you can't see that, but here. Existing list, okay? So we'll want to do an update for that. But for now, let's, either way, whether we are beginning or not, we need to link this. So we have a list somewhere here. There's a list over here, and we're trying to insert before this. So the two scenarios could be that this is literally the beginning of the list with a head pointer, or that we're actually somewhere in the middle of the list and they were stopped before it, and we're trying to insert right in the middle there. Okay? So either way, what we need to do is we need to take our brand new node, which is this one, and we need to change this pointer and make it link to that. Okay, so we're going to do that. And then we're going to see what this currently was pointing to before. So we're going to look at this pointer, and we're going to take that value and we're going to copy it over to here. So that now this points to either something before it, or in the case that it's at the beginning of the list, then that's just going to be pointing to null. So we're just going to copy the null over. So either way we copy it over, we don't worry about it. The only thing is, if we are at the beginning, we need to update the head pointer then. And if we're not, then we don't need to update that. Okay? So that's the only thing that we're going to have to do. So if cur was currently the head, we will want to update the head pointer to now cur to point to the temp. Okay? But only if this is the case. Let's insert it. So we got to do those pointers. So let's start with the green one. So that's currently temp next. We got to update this somehow, and then we're going to have to update temp prev. Those are the two pointers that we're going to have to update. And we also need to update cur next, or sorry, cur prev to point back to us. And the one before cur, if it exists, we also would want that to point ahead. But that may or may not exist if we have the scenario here. Okay? So those are the potential pointers that we need to update. So let's start. So term next, we want to point that to the cur because that's going to go before the node. So that's saying the green one that we have here. So we want to update this to point to this. So just copy cur because this is currently pointing to cur. prep is going to point to whatever curve prep is pointing to, which may or may not be null. If it's null, that's because it's the first node. Doesn't matter. It copies null over. Big deal. All right. So now we have basically pointed our node to the one before and the one after successfully. So we have this pointed. We have this pointed. Now what we got to update is this one here to point back to our node. And then if there was a node before us, we want to update that pointer next to point to our new node. Okay? So we don't want to do this update until we figure out that other scenario. Okay? So how do we figure out if that node is a valid node? Well, we can see what is here. If this is currently equal to, if this is not equal to null, if curve prep is not equal to null PTR, that means that there's a node before us. And then we can actually update that. So there is a node before us, so update its next pointer to point to our new node. Okay? So we're going to access that by saying curve preps next. So that's saying access the previous node's next pointer. So, whoa. That's saying take the previous node, so use this arrow to get to here, and then access this next pointer, so access this one. Because we want to update that to point to that. We want to make it point there. Okay? So, but we only do that if it exists. That's what we do in this null check before. And we're going to update that to point to temp. If it doesn't exist, then this is actually another scenario where you can just say else must be beginning of list. And if that's the case, then that's literally the same thing that we have here. So we could actually go ahead and do the hGetsTemp here. We could do this code, or we could leave what we have here. Either or. Just don't, I mean, you can leave them both actually. I'll leave them both, but you don't need them, okay? You know, no, I don't like leaving both. Let's just uncomment one. We'll uncomment it later, okay? All right. So finally, now that we've updated this previous pointer, we can update this ctemp, which is the next node, to point to temp. The reason we do this at the end is because we, as you see, we are accessing this stuff here. If we do this line up here, so if I move this code up here, then this code won't work because we lost the pointer, right? So that's the last thing we want to do. So make sure you do this last. I am, of course, going to be uploading this after class so that you have access to it. Be very useful for your exam and your homework. So, yeah. Okay, that takes care of inserting at the beginning and inserting at the middle. No more worries. The last thing we need to do is we worry about inserting at the end. So how do we know that we got to insert at the end? Well, when we hit the last node, we get to the null, and then we know we're done. So we'll be out of the loop. But before that, make sure that you add to your loop two things that we forgot last time. When we finish inserting, get out of this function so that we don't keep looping. That was the bug that we had that last time. And the other thing is, make sure that if you are not inserting anything, then go ahead and update your curve pointer to point to curve next, right? Okay, so that updates the next pointer. Finally, like I said, if we get out of this loop, it is because we did not find a number that was smaller, or sorry, that was smaller than what we're trying to insert. So our C was always bigger. If that is the case, that it happens, it's because we need to insert all the way at the end of the list. So let's just go ahead and do that. All right, so to insert at the end of the list, we just need to worry about updating a couple of pointers here. So if this is the last number of the list, we hit a null. We have the tail pointing there. So, and we have our new node that we're inserting, which is our temp. So what we gotta do is we gotta update this pointer from null and make it point here. This is already set to null, so we don't need to worry about that. So the only other thing we got to do is we got to update the temp preb, which is this one, and we got to make it point to what was previously the last node, so what the old t is. And then once we finish doing all of that, we want to update t to point to the new last node, which is that. Okay? So we gotta do all of that. All right, we gotta be careful again on how we do this. So the first thing we gotta do is we want to say that the temp next, that is already set to null, so no worry about that. The temp prep, we want to point to currently the last item of the node. Now we can't use cur because cur is currently pointing to null, but we have a tail pointer, so we can just use the tail pointer. Bam, done. Tail pointer, nice. Next, we want to update the current tail pointer's next, which is currently set to null, to point to the new tail, which is temp. That takes care of the second pointer. So again, line 54 here is doing this update, and then line 55 is doing this update. The null is already set in the constructor, so no worry about that. And finally, we just need to update tail from here to there, so that is just going to be tail gets temp. So that's the brown. 3 lines of code, 3 pointers that you gotta change, and you're in business. Okay, fingers crossed, this whole thing is working. And it only took us, what, 45 minutes. Let's see what the errors are. Probably some simple stuff. All right, so semicolon there, not bad. Doesn't like, no semicolon there. Where are my errors? No errors. Oh, new node T. If head, that should be H, not head. I like how it's not showing me the errors at this point. That's sad. Clear filters. Oh, I have some filters set up. Okay. D. What is D? This should be cur dash D. And that's probably the same issue here. There we go. Okay, so it was working. We just needed some semicolons, some variable naming issues, basic stuff. Okay, whether it really works is what we're about to find out. So let us try to insert stuff and then print it out. So let's make a DLL, double linked list. We're gonna call it just L1 for list 1. And then let's try to insert. Why is that underlined? Oh, I gotta give it the type. So let's make it integers first. Then we can make one with cars or something, just to show that the templating system works. So let's insert a bunch of numbers. Let's try to insert a 6. That's gonna test. We want to test all 4 cases, right? So obviously that's gonna test the case of being empty. And then from there, we can test the case of inserting at the beginning of an existing list by putting a number that's smaller. So let's put a 3. Then let's test the case of inserting at the end of the list by putting a big number. So let's put a 9. And then let's test the case of inserting in the middle by putting something at 4, which will put it between the 3 and the 6. Or, yeah, let's put it at 7 so we can test near the end. And then that should test all cases, but, you know, for safety, let's just insert a number more at the beginning, and then maybe like a 4, okay? After we insert these things, though, let's call print. So let's call it after we do all 4 test cases first. So 6, 3, 9, 7, and let's do L1.print. And after we insert the other two things, let's try to print it reverse. Moment of truth. What do we think? Is it going to work the first time or not? Historically, when I coded a double linked list, I had a semester where it worked fine the first time. And I have other semesters where it had a bug. So we got more like 50-50. But I'm confident. I feel like today we coded it really well. So I think it'll work, but we'll see. All right, place your bets. And I should do a Twitch poll, but it takes so long. Ooh, that is promising. Yeah, I think it worked. It did work the first time. Ooh, yay. My odds have gone from 50-50 to like 75-25 now. So very cool. Let's see. So the 3 went to the right spot. The 6 went to the right spot. The 7 is in there. Yeah, okay. And then the 1 and the 4. 1, 3, 4. Yeah, so it all worked out. Nice. Okay, my bad. And I did not have I don't have a code on the side here. I'm copying this all from scratch just from doing it. So. All right. And look at that. It's what? It's not that long. It's 60 lines of code plus the print statements. 100 lines with testing code. Okay. All right. So before I do the delete, does anybody have any questions? Let's do actually the deallocation. Might as well do that one. The allocation is going to be like the print statement. Just you call delete instead. So let's just kind of do that. So for the deallocation, we can start with the head pointer, and then we can just go ahead and say, well, cur is not equal to null. Create a temporary pointer. If you don't, I mean, the easy way to do this, but bad way would be like this. Let me show you the bad way. You can say delete on cur, and then just do cur next. The problem with this is that you're accessing a dangling pointer because you just deleted it, and then you're accessing it literally the next line. So what you want to do is you want to make a temporary pointer. And then just store cur next to that. And then do cur temp here. And then do the delete in between those two lines. Okay? So now you don't have a dangling pointer you're accessing when you're doing this. So if you run this again, delete. Oh, semicolon. Right, rogue cout statement. Gotta go out of the way. Okay, let's just really quickly check Valgrind. See if this is okay. Yep, it's good. And let's try to comment out the deletes just to see if that actually would give us the memory leaks, which it should. But let's just do that. So let's comment out the delete right there. Run this again. You can see that has memory leaks, of course. So yeah. So you can see that is actually working. Very good. All heap blocks are freed. No leaks are possible. Those are very confident words from that program. I don't know if I trust it 100%. I mean, for this code, I do, but if I'm running for real code, I'd be like, yeah, I'm sus that you actually can tell me that. Okay, so we still got to do this delete. Now, this delete is like if we want to delete a given number that we pass in. So like delete all 5s or delete all 2s and whatnot, okay? So again, it's kind of like the mirror version of the insert. You know, you got all the cases where you got to delete the beginning and the middle at the end. And if you delete the last item of a list and it becomes empty, you gotta worry about that. And we have the extra level, in addition to having more pointers, that we have the tail to handle. You gotta make sure that if you delete something at the end of the linked list, that you move the tail back. And of course, that if you finish everything, you also set it to null, which is something I actually want to do here. You don't technically have to because the destructor is running when this object is going out of scope, but I feel extra safe doing this. So I'm gonna set the head and tail to be null. Just in case. Doesn't really change anything of the code when you run it. You'll see Valgrind doesn't change. There's no changes and whatnot. But it's a good idea. It's a good practice. So yeah, okay. So I'm not very excited to delete because it's the same thing and it's boring. But we do have 20 minutes left and nobody has any questions, so I have nothing else to show you other than to delete. Yeah. By the way, just really fast, just so you can see that the template part works, let's make another linked list and let's make this one made up of characters. Here, just because I don't want to make the code too long, I'm just going to make it like that, horizontal, so that it doesn't become too big. So I'm going to like A, T, B, another A. Duplicates are good. And then L2 print. AABT. There you go. So you see, it works with more than just numbers. You could do any object you want as long as you have the greater than, less than operator overloaded right here. You don't even need to overload the less than operator, just that one. Literally that operator, and you can put any type that you want. So, but I would overload all of them to be safe. It's kind of risky if the code gets swapped at some point to a less than sign and the whole thing breaks. But yeah. Okay, so for the delete, I am going to start out by putting a loop. I don't need to create a temporary node or whatever because I'm going to just delete stuff. I do want to create my temp pointer, cur, although I called it C, so I'll call it C here. And then I'm going to say, well, C is not equal to null pointer. C gets C next, right? That's my main loop. Now I just gotta see if I find it. If I find it, I want to delete it. So before I even do anything, let's see if the list is empty. And if it's empty, don't do anything because otherwise you'll crash, right? So if head is equal to null PTR, then just return, right? You can put a CI statement and say like list is empty. Or you can just do nothing. So either or. I'm actually not going to do nothing. But I'll leave it there in case you want to play with it. Okay? So now we know that the list is not empty. So that means that we may have to delete something. We may not if it's not found. But the point is now we can actually start looking. Okay? So how do we know if what we want to delete is what we find? Well, we just look at what we're looking at. So what is D looking at? Is that equal to what we want to delete, which is the content of B? So if that's equal, we found something to delete. Right? If it's not equal, then we do nothing. So we just keep going. In fact, in my first iteration of this function, all I'm going to do is search and find and not do anything. Just to show you that it works. So we'll say B has been found. So this is all the code that I write. And I run this. And again, to make it easy, I'm going to put these all in the same lines. Save some space. You'll see that the output shouldn't change. But now let's just say that I want to delete the 1. Or, yeah, let's do 1. So L1 delete 1, and then let's try to do L1 delete 2, which I don't think we have a 2. Okay? If I run this, you'll see that we have 1 has been found, and you get nothing for 2, right? So we know that our search function works, and it is able to find the items. So now all we gotta do is delete the item. Okay? Now easier said than done, but still. So I'll leave that comment out in case you want to play with that later. And I'll just go ahead and write it. So let's delete it. So the act of deleting is nothing more than moving pointers around to kind of patch up where things are at. So if it's at the beginning, then that's great. That's kind of like the same thing you do with the singly linked list. You just delete it and change the head pointer. So let's say that what you're trying to delete is at the beginning. Well, if this is what you want to delete, you're going to have to update the head pointer here, and then you're going to want to update this previous pointer to null, so it points to null. Do that and you're done. So let's do that. So if cur is equal to null, at this point in this if statement, I am at the object I want to delete. Okay, that's already there. So I want to see if this pointer is pointing to the head, because, or they're equal, or they're both the same. Because if that's the case, then that means that this is the head that we're deleting. Okay, if the head is what we're deleting, what we need to do is we need to just update the head pointer to point to the next item. So head is going to be to the second item. Okay, this may be null if it's the only item in the list. That's okay. It's not going to crash because it just copies null. It's just copying a null over, so no problem there. Okay, what I do want to do is, of the second node, I want to update that pointer to be null. But I don't know if there's a second node, because it could be just one item in the list. If that's the case, then I want to check that before I access it. So similarly to how with the insert, I did this check here that I said if this is not equal to null, then do this. I'm going to kind of do the same thing but reverse for the deletion to make sure that I don't crash. So I'm going to say if C next is not equal to null, then I know it exists, and I can go ahead and say C next pref gets null. Okay? Or actually, you know, to make the code more flexible, I want to make that point to whatever the node I'm deleting points to, because that might actually be another valid value. So I can do that to make it so it's writing less code basically. So I can say make that point to whatever previous is pointing to what I'm about to delete. Okay? Yeah. So what I'm saying is, instead of just making purple point to null, I'm saying, or pink this one here, I'm saying copy this pointer. If this is null, because it's the beginning, then it'll copy null. But what if there's another node here? Then bam, I already took care of that scenario. So, you know, two birds with one stone kind of thing. Okay, so I like leaving this at the bottom just because it looks nicer. So I'm going to put that there. But other than that, I think we are set for the front. So we got previous pointer being updated. We're not inserting, so I don't have to change any temp pointers. So yeah, we update the previous, we update the head if it's the beginning. We're good. At least we're good for the head. But what if we have that scenario where we're deleting something in the middle? If we're deleting something in the middle, we already took care of the purple one here, but we need to take care of this pointer, which is the one that's pointing to whatever we are deleting to. And we want that to point to the one after what we're pointing to, which may be null, again, if it's empty. We want to do that. So let's do that. That's just another line of code, but again, you only do that line if such a node exists, which means that we need to check if the node exists. So we can do that here. So if C previous, which is if there's a node before the one we're deleting, if that exists, so if that is not equal to null, go ahead and update that next pointer to point to the node after the one we're looking at. So C next. That will take care of the green pointer. Okay? So we took care of the one before us. We took care of the one after us, pointing back to us. And we took care of updating the head pointer in the scenario that this is the only node. Now there's one more update we have to do. If C is equal to the head, we do that. But we also need to see if C is equal to the tail. If C is equal to the tail, it means that we are deleting the last node. And we need to update the tail pointer. So we need to update the tail pointer to be pointing to the one before it, which may be null, or it may not be, but that'll take care of it as well. Okay? So that's pretty much it. That takes care of all scenarios except for deleting at the end of the list. Actually, no, we already took care of that as well, because if we hit the null here, it means that we didn't find what we were looking for. So, you know, you can always put a cout statement here saying cout like item not found if you want, but I'm not going to. Now you got to make a decision. Do you want it to delete every instance of this or just the first instance you see? If you just want it to delete the first instance, then just go ahead and write a return statement here. If you want it to delete all instances of this, then you want to make sure that you don't run into the issue that we ran last time where it skips deleting some. You have to reset it. So put a return if you want to delete only first instance of what you search for. Okay? If you don't, then make sure that you go ahead and reset the loop, basically. Okay? Go ahead and do continue otherwise. And you could do continue, or you could do something like C gets head, and then continue. So you don't want to run this line of code. Okay, so either or. I'm gonna go ahead and do the delete all option because it's kind of cooler. Okay, so that should reset it to the beginning of the list. And then continue. Yeah, okay. All right, so let's see what needs to be fixed here so that we can run it. So if C is not equal to, so one sign there, and then here one semicolon. Okay, so let's see if this works. We already did a test and it ran and didn't crash, so that's a good sign. So we tried deleting a 1 and then we tried deleting a 2. As we can see, we knew that, well, you can't see it because I don't have a print statement immediately afterwards, but let's just move this print statement down here so you can confirm that this is okay. So we can see this is before the delete. We can see there's a 1 there. We can see after the delete 1 and 2 that the 1 is gone. I know I'm printing it backwards, but you can see that it's gone over here, right? So the delete worked and it didn't crash trying to delete something it didn't find. Okay, let us try to delete more things just to make sure that this works. So again, I'm going to do them all in one line to, you know, for space purposes. Let's try to delete something in the middle, so like a 6. Let's also try to delete something at the end, so like at the 9. So we got beginning, middle, and end, and we also need to test the scenario where it deletes the only item of the list. So for that one, we can test it on this A one. So L2.delete, delete the A. So we'll test it if it deletes all the A's, and then so let's print it before it deletes the A's, after it deletes the A's, and then let's try to delete the B, which will be the last item, so it will be an empty list after that. Okay, so run it. Okay, so we can see that it deleted the 6 and the 9, so we ended up with just a 1. Nope, no 1, so 3, 4, and 7. Yep, so that worked out pretty well. No errors there. For the A, it deleted the 2A, so it is working with deleting duplicates. And then it deleted the T. or sorry, the B. Oh, we still have a T. Here, let's delete the T too then. I want to see an empty list being deleted to make sure that edge case is working fine. There we go. That deleted it, so now it's empty. Okay? So, yeah, I like it say, I want it to say empty. So I'll do a little if statement here. If head is equal to null PTR before this, I want to see out empty. It looks cooler that way. Oh. SS stream. There we go. See? Empty. So there you go. That is your delete. So we've achieved a doubly linked list, fully coded insertion. And it's not any kind of doubly linked list. It's a sorted doubly linked list. You can insert, you can delete. It's templated. You saw it work on templates. You have a destructor. You have a constructor. I mean, that's probably like the assignment you already did, right? So yeah, you got a working copy of it if you couldn't get it working. So that's a lot of coding for one day. Glad I'm not taking the class. All right, so questions, comments, concerns, fears, share everything. Like I said, that's it for the day. Next week, or not next week, this Wednesday, we're going to start talking about stacks and then queues. So, yeah, darn. So I guess we'll be done on the 22nd, actually, because we did finish linked list today. So, yeah, I guess we'll have to figure out what to do for the last days of class. We'll just do long reviews, or not have class, or do like a random topic for fun. Whatever you all want to do. Python? I don't know. Well, I already got a ton of videos on Python. That's not fun. We'll figure something out. Well, I see no questions. Hopefully you all are still awake and here. But either way, that is the end of the class. So thank you all for watching. And I'll see you on Wednesday for stacks and queues. We'll start probably with a stack on Wednesday. Yes, true. All right, don't forget to send me a message if you redeemed any points so that I can award you. And like I said, I'm gonna start uploading the videos because they do take some time to upload. And then once I have them going, then I'll do the points. So I'll see you guys Wednesday. Bye, everyone.